The reason we're going to be looking at this limit is not so that we can show you a technique that you're going to be using a lot. What we want to be able to do is show you how we can rewrite this to use Calc 1, and then actually it's going to be the rewriting that's actually more important than the actual evaluation of the limit. So what I'm going to do is first see if we can't do this with plugging in. If I put a 0 in for x and a 0 in for y, I get the sign of 0. The sign of 0 is 0, so I get a 0 on top. If I put in a 0 there and a 0 there on the bottom, I get 0. So what I get is 0 over 0. The next step in Calc 1 is to try to do some algebra. There's not any nice algebra that I can do to cancel that x squared plus y squared, or almost really to change this in almost any way. I guess I could make a big mess of this by using trig identities, but that doesn't actually help with the limit, so I'm not even going to try it. This is what we're going to do. I'm going to rewrite this right here, because here's the point. Let's go like this. I'll draw a picture and then we'll just put it in. Yes, here's the point 0, 0. If x, y is a point that's close to 0, 0, being close to 0, 0 really means that the distance between them is very small. Now the distance between x, y and 0, 0 is just this. So saying that xy is close to 0, 0 is exactly the same thing as saying that the square root of x squared plus y squared is tiny, like that. Now, by the way, saying that x squared plus y squared is tiny is exactly the same thing as saying x squared plus y squared is tiny. You might have seen this in linear algebra when you were trying to look at vectors and see how big they were. But meanwhile, what does it say? This says, instead of saying, I want to take the limit as xy goes to 0, 0, I can put something else in there instead. I can put that the distance squared between them is getting small. That's a crucial rewrite. And here's why. We want to be able to use this fact from Calc 1 and Calc 2 that you hopefully have seen a lot, right? That if we have the limit of sine of blob, I guess I'm just going to put a blob over blob, and as long as blob gets close to 0, the answer is going to be 1. This gets used a lot in Calc 1, it gets used some in Calc 2, but as long as this, and this are all exactly the same, the limit is going to be equal to 1. Now, how does that help here? Whoa, it gives us the final answer. Yes, because what we have is the limit as blob gets close to 0 of sine of blob over blob. Well, that tells us the limit is 1. And so what we needed to really do to do this problem was recognize that we had sine of blob over blob, and then do this crucial rewrite. But this rewrite is going to show up a lot this semester. So it's saying that a point is close to 0, 0, if and only if the distance squared between them is getting close to 0, or the distance is getting close to 0. But that way, instead of looking at two different things, we get to look at one quantity getting close to 0, and again, we can try to use a Calc 1.